Hey guys, so this is a quick lesson on 3B, which is solving quadratics by graphing. So we've started, there are different ways of solving quadratics, and solving quadratics means find the solutions, which basically are the x-intercepts. So basically, when we say solve, it means find what x is equal to when the function is 0. If you remember when we did factoring, right, we had like, let's say x squared plus, let's say 5x plus 6 equal to 0. And that was the previous lesson on solving by factoring. We ended up factoring this, what two numbers multiply to 6, add up to 5. And let's say we say 2 and 3, and then we end up writing x plus 2, and then x plus 3 equal to 0. And then we say, okay, by the zero product property, x is either -2 or x is -3. Now, what do we mean by that, right? Which is going to lead to this lesson. What do we mean by x is equal to -2 and x equal to -3? That means if I were to draw or graph this equation, this quadratic, right, it's going to end up cutting the x-axis at these 2 points. So in this case, let's say I'm using this graph here. It will be, let's say, -2 and -3, and something maybe like this, right? Something like this. So this would be our quadratic. So when we're finding solutions for quadratic, when we're solving for quadratic by graphing, we're actually looking for these, what we call the x-intercepts, right? Where the graph meets the x-axis. And that's technically, remember, these are the values, right? These are the values that make the whole equation equal to 0. Remember, the whole equation, that's the y, right? So these are the x values that make the y value 0, meaning I have these 2 points, -2, 0, right? When x is -2, the y value is 0. And when x is -3, the y value is 0. So these are technically my 2 points, -2, 0, and -3, 0. That's what we meant by solving, right? Or we generally mean by solving. Now we're going to take the same concept of solving, right? But instead of doing it algebraically, like factoring here, for instance, we're going to do it by graphing. So we're going to graph and see where the graph cuts the x-axis. Okay, that's that's the intention, and that's the purpose of this lesson. So, so to fill this out, it says the blank of a quadratic equation are called the blank of the equation. So we can say, and again, we're using this vocab bank here, word bank. So which ones, right? We can say the zeros, and that's using this word, are also called the roots. We can call them the roots, we can call them the solutions, right? So these are the same solutions. These are the same words, technically, roots, zeros, solution, they're interchangeable. Then it says one method to finding the roots is to find the blank of the quadratic function. So it's to find what? The x-intercepts, which are also the same thing, of the quadratic function. The blank of the function are the blank of the graph. So the what? The blank of the function. I mean, again, we can use them interchangeably. We can say the zeros of the functions or the solutions of the function, right? The solutions of the function are the what? Are the, we can say the x-intercepts of the graph. So when we're finding solutions, graphically, we're finding x-intercepts. That's all you need to get out of this. So how does it look like? How does it look like when we have one solution, one real solution, two real solutions, or no real solutions, right? Because these are the three options when you're graphing. Because think about it, you have a parabola. So your parabola is either going to cut at one point. So your parabola may look like this, right? And if your parabola crosses, this is the x-axis here, and this is the y-axis. If it crosses it at one point, that means we have one solution. Remember, 1 point, when we have 1 point of intersection, that means what? That's equal to what? One solution. And it may be opening downward and something like this, right? That's also possible. That's also one solution. So it could be this or it could be that, right? One or the other. Now, when do we have two real solutions? Two real solutions, that's when we have 2 points of intersection, when your parabola crosses something like this, right? Or it may be crossing something like this, right? Actually, let me make it more clear so it's not confusing. It could be something like this, right? I'm showing both of them, so just to tell you that, you know, it could be open upward or downward. So these are examples, right? But again, it's one or the other, right? We can have both simultaneously. So if your parabola is something like this, that's two solutions. So 2 points of intersection, 2 points of intersection with the x-axis. Basically, that's two solutions. So 1 point of intersection with the x-axis is one solution, 2 points is two solutions, and no real solution is when you do not have any points of intersection. So when your graph is upward like this and it does not cross the x-axis, that's no solution, right? This is no solution, no points of intersection or no point of intersection. That's no solution. Okay. Now it could be what I just showed you here. It could also be downward. It could be something like this, as long as it doesn't cut or cross the x-axis. So this is basically what solutions are, right? 1 point of intersection, one solution. 2 points of intersection, two solutions. No point of intersection, no solution. These are the only three options that you would have for quadratic when you graph it, right? These are the three and only three options. There's not going to be a fourth option. So having said this, let's move on to the first example. Solve quadratic equations by graphing. Now, if you remember the standard form, this is the standard form that is given to you here, which is technically ax squared, right, plus bx plus c. And always make sure you write it in this order, right? X squared first, then x, and then the constant, if any. Now, we identify a, b, and c first. A is the number, the coefficient of x squared, which is the leading coefficient. In this case, it's a hidden one. Don't forget that. Don't say it's 0, because this would be 0 if you said it's 0, which is not true. So a is 1, b is 6, and c is 5. Now, how do you solve by graphing? How do you graph this, right? How do you graph it from scratch, from just the equation? So you can do it in different ways. I personally prefer table of values of 5 points. If you recall, we've done this quite a few times. And in this table, we have 5 points. And in the center of the point, we're going to have the vertex. So 1, 2, 3, 4, and let's extend this a little bit more. This would be the 5th point right here. So in this table of values, we're going to start with a vertex. How do we find the vertex? If you recall, the x value of the vertex, I'm going to call it x of v, is negative b over 2a, and that's something we've done in the past. So in this case, negative b would be negative 6 over 2a is 2 times 1. That would be negative 6 over 2, which is just negative 3. This is the x value of the vertex, which is basically here in the middle always, right? Now, the corresponding y value is the y value found when you take the negative 3 and plug it into the equation. We have to do this correctly, the y value, right? The y value of the vertex, y of v. How does it work? Okay, remember, the key was erase the x, replace it with pairs of parentheses, right? That's a good practice right here. And then inside the pair of the parentheses, just plug in the negative 3, the x value. And then solve. Negative 3 squared is positive 9. 6 times negative 3 is negative 18, and then positive 5. 9 plus 5 is 14. 14 minus 18 is negative 4. So this would be negative 4. And then if you recall, we find 2 points left of the vertex, of the x value of the vertex, and 2 points right of. And then we kind of promise that this value and this value will be the same, this value and this value would be the same, right? So that's why we put the vertex in the middle, so it's easier for us to find the, let's call them symmetrical values, right, from the x value of the vertex. So how do I find those values? I try to work with the smaller values, like negative 2 and negative 1, rather than plug in negative 5 and negative 4. So let's try negative 2. Negative 2, if x is negative 2, I'm technically saying what is f of negative 2, right? I'm plugging in negative 2 into the equation, or y at negative 2. That's going to give me negative 2 squared plus 6 multiplied by negative 2 plus 5. And this will be 4 minus 12 plus 5, which is going to be negative 3. So negative 2 gives me negative 3, and so will negative 4. We know that by symmetry. If I want to find f of negative 1, let me just create here a barrier. F of negative 1, that's plugging in negative 1 into the equation. So negative 1 squared plus 6 times negative 1 plus 5. And that's going to be 1 minus 6 plus 5, and that happens to be 0. So I actually found a couple of zeros, right? A couple of the intercepts. So now I can graph. So it's easy from that point because I have my 5 points, including the vertex, which is here in the middle. My vertex is 3 to the left, 1, 2, 3 to the left, and 1, 2, 3, 4 down, about right here. Then negative 2 is negative 3, and so is -4 is -3. Right? And then -5, 5 left, and 0. So this point and also -1, 0. They're symmetrical. They have to be symmetrical, okay? And then make sure when you connect them, it's a smooth U-shaped curve and with the arrows. And if you want to put that the vertex is -3, -4, even better, or if you want to highlight the points, that's better. But as long as you have the table, I would know. Technically, that helps me know that your points are graphed correctly. And make sure you graph your points correctly, okay? Be careful with that. Highlight them, like basically show them, right? Like I am here. Show them exactly where they are, the 5 points. Because 5-point graphing is important. 5 points on graph. And that's how it works. So again, what were the steps, right? To go back. Step 1 was to find A, B, and C, right, from the equation. Step 2 was to find so this is step 1 here, finding the A, B, and C. Step 2 was to find the X value of the vertex from -b/2a. Step 3 was to find the corresponding Y value of the vertex. And then step 4 was to make basically a table of values and plug in really the numbers. And I can find the others by symmetry. This is super easy. If you repeat this process over and over again, then that's pretty much all you need to do. All right, so I'll let you try example 2 on your own. Okay, and you can try that and let me know what you get. You can let me know in class, verify with me in class to make sure that you got it correctly, but just follow these steps, okay? And this is a good practice for you. So this is how you solve by graphing. Now, let me go back, sorry. Let me go back. Because the question was, I forgot to answer the question. That's an important part, right? I did everything but answer the question. Solve. What does it mean to solve, right? Remember, we just said solve means find the X values that make the equation equal to 0. So what makes this equation equal to 0? -1 makes it equal to 0, makes the Y value equal to 0, and -5. These are my solutions. So if I were to say here, solutions, I can say solutions. What are they? X equals to -5, or X equals to what? -1. So these are the values that make it equal to 0. Now, if you want to say X equals -5 and comma -1, that means another X value is equal to negative. That's also acceptable. Either way, it's fine. Box your answer, you're good. Okay, so again, when you're done working, that should be step 5, basically, right? To seal the deal here. So step 5, when you're done working, go back, and that's what I did. I went back and asked myself, did I answer the question? And that's when I knew that I did not. So I had to go back and make sure that I show the solutions. Now, if you also say -5, 0, and or solution is -5, 0, -1, 0, that's also acceptable. You would be showing them as ordered pairs, right? Instead of just X-intercepts. I hope this is helpful here. Let's see. So again, try number 2 on your example 2 on your own. Example 3, you can also try that one. Same idea, it's more repetition of the same. Now, example 4, it says determine whether the quadratic function has 2 real roots, 1 real root, or no real root. If possible, list the zeros of the function. So how do we know that, right? So we can graph it. Again, this is all graphing. Here, in this case, if we follow ax squared plus bx plus c, you'll know that a is 1, right? That's 1x squared. We don't have an x term, so b is 0, and c is -9. So if we find the x value of the vertex, which is -b/2a, that's going to give us 0/2, which is just 0. And it's common. When you don't have an x value, you have x squared, but you don't have an x value, right? You don't have a term in x, so you don't have a bx. You don't have that. That means your vertex has an x value of 0. And you plug that back in there. If you plug in 0, you get 0 squared minus 9, which is -9. That's the y value of the vertex, right? So your vertex is at 0, -9. That's where your vertex is. Now here, I don't know if I scale it by 1, I'm going to be off the chart. So maybe I'm going to go by 2s, 2, 4, 6, 8, 9 would be here, 0, -9. So again, if I'm going by 2s, this would be my vertex. Let me see if I actually can go by 1s. If I go by 1s, I go 1, 2, 3, 4, 5, 6, 7, 8, 9. It's actually the last point if I go by 1s, I believe. Yep, that's the last point here on the on the tip of the arrow. So this is 0, -9. Now, I know the A is 1, which is positive. So I know my vertex is a happy face, right? It's going upward. That's why I knew it's going to go up from here, right? But exactly how? So I know since it's going to go up, it's probably going to cut the x-axis because it's going up and it's going to meet at one point the x-axis. So I know there are going to be roots, right? Now, how do I find them? Traditionally, what we did, and this is side work, the x squared minus 9 was a difference of squares, right? It's x plus 3 times x minus 3. So we know, we kind of anticipate that I'm going to hit the x-axis at -3 and we're at +3. So I know from that. But we probably don't want to, I mean, we can do it this way, right? We can factor this out. We can say this is x plus 3, x minus 3. And then, but this would be solving by factoring. So you don't want to cheat the system, right? You want to, this is to kind of double check that this part here is to double check that your work is correct, right? But to graph it, you need to, so your vertex and you do the 5 points. And you kind of know that -3 is going to give you 0, and so will +3. Your vertex is at 0, -9. You can take 1 point left, 2 points left, 1 point right, 2 point right. And you can plug them in. 1 is going to give you 1 squared minus 9, which is -8. And -1 will give you the same. 2 will give you 2 squared, which is 4, minus 9 is -5. And this will give you also -5. Now, if you were to go one more to the right and one more to the left, that's where you get your zeros, right? So, and that's why sometimes you have to go beyond the 2 points to the left and 2 points to the right, okay? But for now, graphing-wise, so 0 is -9, we have that. 1 and -1 are -8. 1 to the right, 1 to the left are -8, so right here. 2 to the right, 2 to the left is -5, so 1, 2, 3 right here. And you know 3 and -3 are going to give you 0. So right here. Okay. And again, you make a smooth curve. I'm not good at graphing these things. It's a smooth U-shaped curve. Well, it's not too bad. And this is my graph. This is my parabola. This is the parabola that represents the quadratic equation x squared minus 9, or y equals x squared minus 9. So how many roots? We have 2 of them. What are they? What are the zeros or the roots? Are the same thing. You can say they're -3, 0, and 3, 0. And now sometimes I put and like this, okay? Some of you on the test put a U. It's not correct. You don't put a union. It's not a union. This is an and. So I'm going to probably stop putting this and so you guys are not confused. And instead, either put and, right? Or you can put comma. You can put this, or you could say -3, comma 0 in parentheses, comma 3, 0. Okay, either way. What are the x-intercepts? So here, actually, to say this better, let's put the zeros are -3 and 3, right? And the intercepts are what? -3, 0, and or comma 3 zeros. That's a better notation. So you have 2 roots, right? The zeros means the value that makes. So for people to understand what zeros are the x values that make the y value equal to 0, right? And they are 3 and -3, because 3 and -3 are the x values that make the y value equal to 0. So this is pretty much it, right? Determine whether the quadratic function has 2. We did that. We said it's 2 real roots, right? Because it's going to be 2 points here, 2 points of intersection. That's 2 real roots, 2 real roots. Real means on the real number line, like the x-axis is a real number line. We did that. And then list the zeros, we did that. We said there, -3 and 3. So similarly, that's how you're going to do for, what you're going to do for numbers 5 and 6. So for number 5 and 6, you can also think of this also as a difference of squares. Like on the side, you can say it's 3x plus 8 and 3x minus 8, right? And you automatically know -8/3 is going to be a 0, and +8/3 or 8/3 is going to be another 0, right? That's how you can do it. Here, you can, when you're finding zeros, here it didn't say graph, it just said find the zeros. So you can always do factor and find. So what 2 numbers multiplied to -42 add up to -11, and 42 is 1 and 42, 2 and 21, 3 and 14. That's a good one. So you have 14 and 3, but you want them to be the product is negative and the sum is negative, so the largest must be negative. So it's negative 14 and 3. Therefore, this becomes x minus 14 quantity multiplied by x plus 3 equals to 0. And again, by the zero product property, right? By the zero product, we don't have to write it down. But if they ask you, how did you know? The zero product property says this, that if you multiply two factors and the answer or the result is 0, that means one of them must be 0, then x equals 14 or x equals to negative 3. These are your solutions or your zeros or your x-intercepts. Any one of these three terms are interchangeable. Okay, so, and this is pretty much for this one, right? I should have written it here. 3x, remember, it's the difference of squares, right? It's 3x squared minus 8 squared. That's what it is. And that's why I did 3x minus 8 times what? 3x plus 8. And remember, when they say find the 0, that means set it equal to 0. For this to be equal to 0, x would have to be 8/3, the opposite of this number over this number, 8/3, or it's going to be the opposite of this number. This is plus 8, one of them, which is negative 8 over this number, which is 3. So these are your solutions. Okay, so I hope this was helpful. I think this is pretty much it for this lesson. Maybe there are a couple more questions. I'll let you try 7 and 8. Okay. Maybe I'll do one actually. Let's do that. Let me do one because a is not equal to 1. For number 7 and 8, the a is not equal to 1. And there's another video on 3B homework, right? That would help you. So let's try 8, right? For number 8, you can do the x method, which gives you what two numbers multiplied in negative 36. Remember, it's always this times this, right? Negative 36, and add up to negative 5. So 9, I'm thinking 9 and 4 with negative 9, right? That would give you negative 36 when multiplied and negative 5 when added. Now, we cannot do x minus 9x plus 4, right? We can't because we have 3x squared. So when this a here, which is 3, is not equal to 1, like this case, what do you want to do? You want to group. So this negative 5x, what we're saying again as a repetition from factoring, is a negative 5x. The breakdown for it is negative 9x and plus 4x. So we're going to write this as 3x squared. And instead of negative 5x, we're going to write that as what? Negative 9x plus 4x. This is the combination that gave me, or that gives me negative 5x, and then minus 12. And then we factor by grouping. You can do it in a different way, but I think most of you like this grouping, so I'm showing it here. And this becomes 3x times x minus 3, if I were to factor the first two together, and then plus 4 times what? Again, we're anticipating x minus 3. And because I have x minus 3 in common, so it's x minus 3 times what? 3x plus 4. And remember, this is just, let's go back to the question, because the question says solve, find the zeros, right? So what I just did, I factored. I only factored. But technically, to find the zeros, you're setting this to be equal to 0. You're setting this to be equal to 0. You're setting this to be equal to 0. And what makes it 0? X equals to 3, or x equals to what? Negative 4/3. Remember, opposite of this over this, which is negative 4/3. Opposite of 3, negative 3, which is 3 over 1, hidden 1. Or that's easier to see that as 3, right? So these are the zeros. Try to apply this, what I just did here, to number 7 and try it on your own. I hope this was helpful. And if you have any questions, please feel free to ask in class. And I'll see you in class, and good luck to you.